What is Docker? Docker is an open-source platform that allows developers to automate the deployment, scaling, and management of applications using lightweight, portable, and self-sufficient containers. These containers encapsulate an application and its dependencies, ensuring that the application runs consistently across different computing environments, whether it's development, testing, or production. At its core, Docker is based on containerization technology, which isolates applications in a secure and lightweight runtime environment. Unlike traditional virtual machines, VMs, containers share the host operating system kernel and are much more efficient in terms of resource utilization. Why is Docker used? Docker is widely used for several key reasons. 1. Portability. Docker containers are platform independent. An application packaged in a Docker container will run the same way regardless of the underlying operating system or hardware. This solves the "it works on my machine" problem. Containers can run on any system with Docker installed, whether it's on a developer's laptop, a testing server, or a production cluster. 2. Consistency and isolation. Docker ensures that the environment in which the application runs, including libraries, dependencies, and configurations, is isolated from the host system and other applications. This isolation prevents conflicts between applications running on the same system and ensures that the application behaves consistently across environments. 3. Efficiency. Containers are lightweight compared to VMs because they share the host operating system's kernel rather than requiring a full OS for each instance. This reduces startup time and resource consumption. Multiple containers can run on a single host with minimal overhead. 4. Rapid development and deployment. Docker allows developers to build, test, and deploy applications quickly by standardizing workflows. Developers can focus on writing code without worrying about the underlying infrastructure. 5. Version control for environments. Docker files, used to create Docker images, allow you to version control your application's runtime environment. This ensures reproducibility and enables rollbacks to previous versions if needed. 6. Scalability. Docker makes it easy to scale applications horizontally by spinning up additional containers as needed. Tools like Docker Compose and orchestration platforms like Kubernetes or Docker Swarm can manage scaling. 7. Easier collaboration. By providing a consistent environment, Docker simplifies collaboration among development, QA, and operations teams. Teams can share Docker images containing all dependencies, reducing the need for lengthy setup processes. 8. Integration with DevOps practices. Docker integrates well with DevOps pipelines, enabling CI/CD workflows, automated testing, and seamless deployments. Key Docker components. Docker Engine, the runtime that builds and runs Docker containers. Docker images, read-only templates used to create containers. These are like snapshots of an application's environment. Docker containers, instances of Docker images. They encapsulate the application and its environment. Dockerfile, a script that contains instructions for creating a Docker image. Docker Compose, a tool to define and manage multi-container applications using a single YAML file. Docker Hub, a public repository for sharing and distributing Docker images. Example use cases of Docker. Microservices. Docker simplifies the deployment of microservices by allowing each service to run in its own container with its dependencies. CI/CD pipelines. Docker enables the creation of lightweight, disposable environments for testing and deployment in continuous integration/continuous delivery pipelines. Application modernization. Legacy applications can be containerized for improved portability and efficiency. Scalable web applications. Web applications can be easily scaled by deploying multiple instances of containers and managing them with orchestration tools. In summary, Docker revolutionizes how applications are built, shipped, and run by leveraging containerization to provide consistency, efficiency, and scalability across development and production environments.